Hello, my name is Srinivas Pasha, and today I am here to discuss about the Spring Security implementation part with JWT. There are various token signing algorithms in the market like HMAC, RSA, ECDSA, etc. So these token signing algorithms can be used with JWT in order to develop or implement highly secured based applications. So today we are going to use RSA, which is one of the most popular and widely used algorithm to implement JWT. Let's have a look at the definition of JWT. So JWT is a JSON Web Token, which is an open standard RFC 7519. These are the internet standards that defines a compact and self-contained way for securely transmitting the data or the information between two parties or multiple parties as a JSON object. So this information can be verified and trusted because it is digitally signed with a key. A JWT consists of three different parts. The first one is the header, which specifies the signing algorithm. In our case, we are going to implement RSA. So RSA will be the signing algorithm over here in the header. And the second one is a payload, which contains the claims. So example, the user information and the rules associated with the user, what authorizations or what actions he can perform with this roles and all this kind of things. The third one is the signature, which verifies the sender of the JWT itself. Okay. So let's look into this HMAC algorithm, which is the commonly used algorithm for implementing the JWT. So here we have the secret key, which is used both for signing and verification of the token, and also it can be used to encrypt and decrypt the token as well. If an attacker gains access to the secret key, then he can create and validate the tokens. And also he has the ability to forge the token as well. So let's say the user is logged in, and the anonymous attacker can forge the token, and probably he can do whatever the actions that he wants and request whatever the data that he wants from the server with this token forgery without the intervention of the users. This is something called a token forgery. To avoid this token tampering and forging the token, so we do have something to eliminate this, which is something called RSA. So when we actually use RSA asymmetric encryption with JWT, so we will be not giving any option for the anonymous attacker to forge the token or to tamper the token, something like that. Okay. So here RSA is a widely used public cryptographic algorithm. So here in terms of signing and verification, private key is basically used for signing the JWT, and public key is basically used for verifying the signature of the JWT, whether it is valid or not. In terms of encryption decryption, public key is basically used for encrypting the data, and only the associated private key will be used to decrypt the data. Okay, so don't worry about this terminologies. I'll make you understand everything when we do hands-on. So let's have a look at the sample web application which uses JWT HMAC algorithm implementation to implement JWT tokens. So let's say we have the end users like buyers, clients, loyal customers, etc. And we have the servers where our applications got deployed. So these buyers or these clients or these loyal customers will pass the JWT token by encrypting some sensitive data in the form of token, and they will be able to pass this JWT token over the web through the API gateway to the server. Now the server will use the secret key, because the same secret key is being used by the customers in order to encrypt some data from their side, and they can be able to send this JWT and sensitive information over the web to the server. Now the server will validate the token and decrypt the token and analyze the token. After doing all the validations, if the token is valid, then probably it is going to respond to buyers, it is going to respond to clients, and then probably it is going to respond to the loyal customers, whatever the data that they need from the server. Okay. So now let's say in between the request, let's say the anonymous attacker comes, and then probably he is going to, access the secret key. And this anonymous attacker will have the ability to tamper the token as well. Let's say the token is going to contain some user information in the role. He might be able to change the role, and then probably he is going to send that token to the server, and the server will never understand that this token has been tampered or this token has been sent by this anonymous attacker or not, right? Because the same secret key is being used at the end user's platform and also at the server side. So there is no chance for the server to know that the token has been sent by the anonymous attacker. Imagine that this is a financial data, and the anonymous attacker, when he gains access to the secret key, he will be able to decrypt the data, and he will be re-encrypting the data, and then probably he's going to send the data to this server, and the server will understand and validate the token, and if the token is valid, then probably it is going to respond to this anonymous attacker to respond back with the data. Okay. So in order to avoid this kind of token tampering, we have something called JWT asymmetric encryption with RSA. If we are going to use this kind of RSA asymmetric encryption, the token tampering will never be done, because here we have the concept of two different keys. One is a public key and another one is a private key. The private key is never shared to the end users. It is completely securely stored at the server side. And this public key and this private key are mathematically linked to each other. Let's say this public key is being issued by the server itself, and whatever the token that they are going to pass, this JWT token has been issued by the server itself. So there, this buyers, clients, and loyal customers have got this JWT token during their login stage from this server itself. Now this JWT token has been issued by this server itself by encrypting the token with this public key and signing the token with this private key. Now whenever this token comes to the server will understand that the JWT has been associated with the private key, because it has been encrypted with the public key. Only the associated private key will be able to decrypt it. Let's say in between the requests, let's say if this attacker is going to modify the token, he will never be able to modify the token even if he is going to gain access to the public key, because he needs a private key to sign the token. Now there is no possibility for this attacker to request some data from this server back to his side. Now what he is going to do, let's say he is going to generate a new token, but the token has been not signed by this private key. The anonymous attacker still going to send the JWT token signed, encrypted with the public key, because the public key is only used for encrypting the data, but there is no private key associated with it. So while the server is going to decrypt the token will be simply rejected, and the anonymous attacker will never get this data back from the server, because the server understands that it's a new token, and the token, while decrypting the token is not associated with any of the private key association. So an attacker will not be able to decrypt the data, or he will never be able to get the data from the server back. So this is what the RSA asymmetric encryption algorithm solves for us. Now let's do hands-on to implement JWT by using RSA asymmetric encryption. So first we will be creating a Spring Boot application with user controller with a simple get endpoint, and then we will add Spring security dependency, and we will rerun the application. When the user calls the get endpoint, it will simply show the login form by default, and this is the default behavior. So we need to create a bean of security filter chain, which is the first entry point. When we call our endpoints, there's a first entry point where this filter will check the endpoint URL, whether it is public or not, and whether it needs to be authorized or whether it needs to have some token in the request to access the permission to hit the endpoint, and all this kind of steps. So it will determine all this kind of steps, and then probably it will allow the user to hit the endpoint. So we'll do all those steps in the future steps, and then probably we need to make that get API as a public endpoint. Okay, so let's do this first step immediately. So I will be using the IntelliJ IDE for the coding part. I've already created a skeleton of this project where I have created DTO entity repository service for time being. There's nothing inside the service we'll be doing and implementing it from the scratch. And also in the application.yaml, I have created the database and related details. So we don't have to concentrate on this. Okay, so our concentration is completely on the security part. So let's close this and create a API package. And let me create user controller. And let me add the basic annotations to make this as a controller class. I will be adding request mapping, and I will be versioning the API like this. This is helpful for versioning our APIs. Now let's implement the test endpoint. It's a simple git mapping, and I will make this as test. Return user test endpoint. Now let's start our application. The application is started, and let me add a local host. It is already there because I have already tested it. And we got the endpoint. Okay. Now we need to add the security dependency. I'll just go and add that to JPA. So we don't have to add Spring Boot Starter Security, which is not needed. We have something called Spring-Boot-Starter OAuth to resource server. And if you just go inside this, we already have the security related kinds of dependencies. Okay, so that's the total go. I'll reload the project to have the dependencies in my class path. Now, if I just restart my application, now I'll just go to the Postman and I will just hit the endpoint. So now we are going to get 401 unauthorized, and I have also said that by default it is going to return as the /test. It is going to return the login form. This is the default behavior, but we don't want this login form to implement authentication for our application. Okay, so I just wanted to define a separate configuration file with security filter chain as a instance to be created. So here I will just go to the package and I will create a new package config, and I'll just create a new class, user management security config. Now I'll just expand this. I'll use the basic annotations like configuration annotation to make this as a configuration class. Next, we need to prepare a bean of security filter chain. So this security filter chain will check the incoming request first, and then only it will reroute our request to the respective controller endpoints. So since we are working on HTTP endpoints, I need to provide the HTTP security for the endpoints that I have in my application. For that, I just wanted to take the reference of HTTP security, and I just wanted to annotate this with the bean annotation to register this bean with the application context factory. Now I'll simply use the HTTP security dot. I just wanted to define the CSRF. So CSRF is a cross-site request forgery. So this is one of the security attack that we can have for our application. Now, when we are actually dealing or working on front end and front end is interacting with the back end, then probably we need to concentrate and implement this CSRF token, because it always expects some CSRF token to be passed to avoid some security attacks. So as we are completely working on the back end, there is no front end involved, so we can simply disable this. Okay, since it is going to throw some checked exceptions, I just wanted to throw exception. And then I just wanted to define my endpoints. We have a single endpoint, which I have to make it as a public endpoint. So request matches So here we can actually define our endpoint, and then we can make it as permission to make it as a public endpoint. Now any other request must be authenticated. And then since we are working on token-based approach, we don't need to maintain any sessions because the token itself will contain the user information, the roles information, and the token expiry related information, etc. So I will simply go and make it as stateless. And then finally we build it to return the security filter chain. Now the step is done. Now we will rerun the application. And we'll test it again. Great. Now we are going to get the response. Next, we need to create RSA public and private keys with OpenSSL. So OpenSSL is a open source cryptographic tool which will be used to create private and public keys. Okay, so let's go to our IntelliJ, and I have already created the private and public keys. So you can go to the readme.md and you can use this command to generate a key pair in the certs folder, and then probably you can create a public key out of this key pair, and then you can create a private key out of this keypair.pem. So keypair.pem is not required once the private and public keys are generated. So I will simply go and delete this. This is not required now. Okay, so I just wanted to go to this config and I just wanted to create a record to define our configuration to set the private and public keys. Configuration, properties. Now here I'll simply go and create RSA private key and RSA public key from java.security.interface packages. So once you define this, the next thing that we need to do from our side, go to the application.yaml, and since we have the private and public keys in the certs folder, we need to define some prefix to set this public key and private key to this parameters. So let's do that. So now we can define a private key, class path, certs / private.pem. So what is this PEM file, right? So PEM is basically, we can call it as privacy enhanced mail. So this is a container file which is used for storing SSL certificates and other related private keys. Okay, so let me define the public key, class path, certs public.pem. That's all we need. Now we need to add one annotation called @configuration properties of. We can define the prefix. The prefix exactly has to match with this one, so that it will take these two properties and set that to our java.security.interface private key and public key. Okay, so to make this annotation work, we must add one annotation in the main class, @enable configuration properties of RSA configuration properties dot class. That's all we need to do. Now I will just close all the applications and I'll just go to this one. And next, I need to create user and role entities. So let's go to that. We already have the entities. Let me open the user entity and the role entity. And let me minimize this. And let me minimize the console as well. So if you just go here, I have just created a user entity. I have given the table name as users and also registered this class as an entity with the database to create users table out of this entity. And these all properties are going to act as columns in our databases, in our database table users. Okay. Now this user has a list of roles, and this role is also going to have a list of users. That means one user can have multiple roles, and one role will be associated with multiple users as well. Okay. So here I have used bidirectional mapping. So I have used many-to-many annotation. By default, the fetch type is lazy for many-to-many. So I have made it as acre because roles are limited. We will not be having much roles, most probably 10 to 15 if it is permitted. And I have made this cascade type to all so that if I save the user entity, it has to save the role entity as well in the respective role table as well. Now, if I just go to the role table, if I just wanted to get a role and I just wanted to get the associated users also, I can simply define many-to-many and I can use mapped by. So when user is dependent on a role and role is dependent on user, it's a bidirectional mapping. So whenever we use bidirectional mapping, we can simply use mapped by attribute in the another entity to map this roles to this user over here. So that's all we have. Okay. So now let's close all tabs and let's go to the third step to do further actions. So I need to implement the register and login endpoint. During the registration, we provide the valid details in the form of JSON, and we need to store the user details in the database with password in an encrypted way. So let me go to the IntelliJ IDE and let me go to the user controller. Let me minimize this and I'll simply go and create one public. For now, I just wanted to return void. Later on, we will change it according to our implementation. So login. So this is not login. So this is for register. Now I'll just take the request body as a user request. I already have the user request. So this user request contains the username and the password. This username and password is nothing but email and password we need to pass. And let me define this as a post mapping. And I need to depend on private final user service. And let me add required args constructor to generate constructor only for the final fields. Now let me go to the service. There is nothing inside the service. I will just go to the service and user service IMPL, and I will simply make some changes. So here, I'll just void register. I'll just receive the user request. And now I'll just go to the user service and I'll just override that register method. Now here, I just wanted to add this service annotation to register or create a bean for this user service IMPL. And then I need to have a required args constructor to do constructor injection. So let's depend on this user repository. And let me make this as final. Okay. Now what is there inside this user repository? So this user repository extends the CRUD repository, and it simply has the find by username, which returns the user. That's all we do have. So now what I will be doing, I will be simply using the object mapper to convert user request to user entity. Final object mapper and then I'll just import that. And the first step, this dot object mapper dot convert the user request to user dot class. Okay. Now we'll have the user, and now first I need to create a role for the user. So initially I'll be using user as a role. So let me define the role repository. First we need to search for the role if any role is existed in the database. If not, we'll create a new role. So I simply have the find by role name, and this is something called this one. Okay, so find by role name will work simply over here. Okay, so now let's close everything and go to the user service NPM. So we'll just create a new method, private. I'll return a role. So what I will do, I'll just import this role first, and then this dot role repository dot find by role name, simply pass user, and then dot or else throw. So if there is a role, it will return it. Otherwise, we'll simply throw, and don't have to throw an exception here. We just have to create a new role. Sorry for that. So I'll just use the builder to create a new role. So we can extract this user constant to a separate constants file, but I don't want to do that right now. For time being, I just wanted to stick with this approach. Dot build. Okay, so now we will simply return this. So now I'll just go to this one. I'll just call the get role. I'll simply set that user dot set role, and I'll just pass list dot off, and I'll pass the role here. So, and this one I have already also said that the password must be encrypted, right? So for this, I need to go to the security configuration, and I need to create a bean of password encoder so that I will encrypt the passwords. Public password encoder, and I will simply create a bean for this. Return new decrypt password encoder. That's all we need to do. I'll just go to this one, and I will simply add private final password encoder, and I will just use this password encoder in order to set the password. Password encoder dot encode of user request dot get password. So our password will be simply encrypted and stored in database as a encrypted way, in a encrypted way. Okay. So now once this is done, we can simply use this dot user repository dot save of the user. That's all we need to do. So once everything is done, I'll simply go to the user controller, and here I'll simply call that this dot user service dot register, and I will simply pass the user request. Now I need to return new response entity, and then probably I just wanted to keep this entire thing over here. I think there is no return type from this. Once this is done, we can simply create new user response, there's a generic class for the response. I'll just use this. I'll simply pass user registered successfully. And I will simply send the status as created. Okay. I'll just change the return type to response entity of user response string. That's all we need to do. Okay. So let's check if everything is good. So we have this user, we are getting the role. If there is a role, it will return from the database. If it is not there, then probably it is going to create a new role with the role name as user. And then we're going to set it to the list. And then finally we are saving it. So now I'll just go to the controller and I will simply add this endpoint in the security configuration to avoid 401 error / users. And that's all we need to do. Let's start the application again. Okay, the application is started. I'll just go ahead and localhost is already there. Just create a post request and then I will go to the body. I'll simply define the raw as JSON and then I will submit the username. Just create user@gmail.com and password user@123. Very simple. I'll just send this. And there you go. Our user is successfully registered. So let's check it in the database. We'll just refresh it. And we'll just go to the users. Okay. Then we will verify the role. Okay, good. And then we will verify the mapping. Yes, it's good. So we have created one user successfully. So now we need to implement the login mechanism. Let's go to the IDE and I will just close other tabs. I will just create one endpoint, which is login. So public, I'll just return void for now. Later on, I will decide what needs to be written. Login, and then I'll just use post mapping and I'll just mention it as login. So here, I just wanted to define the same request body, user request, which contains the username along with the password. And here, I'll just go to the user service and then I will just void login in the same request we do have. Okay, I'll just go to the user service INTL and I will just simply override the login functionality. So here, in order to implement the login functionality, first of all, we need to define the authentication manager bin. So this authentication manager bin is responsible to verify the credentials, whatever we are passing. So this is the entry point where this manager will expect some details from the configuration. We need to provide the service with which it is going to fetch the details from the database. And then probably we need to do one more change to the user entity where we need to make the user entity to implement the user details. It is an inbuilt security interface. So again, we need to have a custom user detail service to implement the user detail service. Okay. So why this is required? Because let's say we are going to pass the credentials in the form of email and password. The password is plain, we are going to pass, and then probably it has to compare the plain password with the encrypted password stored in the DB. So this mechanism is automated by this user details and the user details service and the user details. So that's the reason we need to do this two steps together. Let's go to the Spring security configuration. I'll just go to this and I'll just define one more bean, which is something called public authentication manager. And I just wanted to create a bean so that it will be registered in the application context factory. And I just wanted to provide the authentication provider instance. So we have authentication provider interface, and that interface is implemented by this provider itself. So here we need to set the password encoder and which service will retrieve the user details from the database. We need to provide all the details to this DAO authentication provider. DAO authentication provider. DAO authentication provider. So instead of defining like this, I can simply use that. So now we'll just use the DAO authentication provider dot set user detail service. If you see this user detail service, the user detail service is an inbuilt interface which we need to implement, where there is a load by username and we need to return the user details. Now what the first thing that we need to do over here, first let's go to our entity user and let's do the first step. We have to implement user details, and then we need to override the get authorities, and here I need to use roles dot string dot map, and then here I will be getting the role, and since we need to return the granted authority, so this is the interface, and there is a implementation class for that, something called simple granted authority, and we can simply pass the role name to this, and then finally we can return the list. This is the only thing that we need to do. Okay, now whenever we are going to return user, that's simply returning user details. Now what we need to do, we need to set the user details service IMPL. So now let's create the user details service IMPL, user details service IMPL, and this has to implement our inbuilt Spring security user details service. Okay, now we need to override that method, and here I just wanted to simply use the service annotation and required args constructor, and I'll just depend on the private final user repository, and simply go and use this dot user repository dot find by username, and I will simply pass that username over here dot or else show the same exception we need to return, right? So it's a supplier, so we need to return the exception. So new username not found exception, and we can simply say user not found in database. Just as simple as that. Okay, so now we'll just go to this one, and on the top we'll just define our private user details service IMPL, user details service. So here I'll just go and define the user detail service. Now we need to make this as final. Otherwise we need to use @autovoid. So we can simply use required args. We can simply use autovoid also, no problem. But I always prefer to use constructor injection because it gives a simplicity to write JUnit test cases also. I don't have to explicitly set the user detail service. During the mocks creations, I can simply mock those objects and pass those as parameters. Okay. So now I need to give the information to the manager that I have used this password encoder. So we need to refer to the password encoder and return. So authentication manager is an interface. There is a implementation class for that, which is something called provider manager. So to this provider manager, we need to provide the DAO authentication provider so that now whenever the login endpoint was hit, it will simply, the authentication manager will simply use this service in order to load the user by username, and then probably it is going to return user details. Now in this user details, there is something called a get password. So this get password is useful to compare our incoming plain password with the database encrypted password. So that's the total idea why we are going to return the user details. Okay. Now I will simply go to the presentation and we have done all the steps. And now what I can do to complete the login, we need to define the JWT encoder and JWT decoder pins in our security configuration. So now let's go and close everything. And I will simply open the security configuration and I'll just take another dependency over here, private, final, and I need to RSA configuration properties as a dependency because we need to set the public key and private key for the encoder and the decoder. Okay, so let me go and define the JWT encoder from Spring Security OAuth 2 package, JWT encoder. So now I just want to create a bean for this, and then I'll just create a new RSA key from Nimbus. You need to select Nimbus because Nimbus is a team where it has completely implemented the encoding and decoding part with public key and private keys. So this team has completely implemented this RSA asymmetric encryption related steps and all this kind of things. So we'll be using the Nimbus JWT encoder and Nimbus JWT decoder, which is provided in the Spring as a wrapper. Okay. So I'll just use this one. I'll just use the builder, and then probably I will just provide RSA configuration properties dot. We need to provide the public key because this is the public key which will be used for encrypting the data. And at the same time, we need to define the associated private key. That's what I said, right? So this public key and private key are mathematically linked to each other. And then we call a build. Okay. So now it is going to return the JSON web key, JWK from Nimbus. And then we need to create immutable JWK set, and we need to pass the JWT JSON web key to the set itself to make it as immutable. JWK source of security context, JWK source, and now return new Nimbus JWT encoder of JWK source. That's all we need to do. And so let me import this. So this is from Nimbus. Good. Now let's define the JWT decoder. Let's create a bean, otherwise we will get an error while running the application. So return Nimbus GWT decoder from Spring itself, and then there's something called with public key. So here in the decoding part, I don't want to decrypt any data. Instead, I'll use the public key in order to validate the JWT, whether it is valid or not. Okay. So RSA configuration properties dot public key dot build. And that's all we have to do. Okay. Now, what is the next step? Let's go to this. So we have defined this JWT encoder and decoder. And the last service we need to implement is token service. So let me go and define this one as well. So let me go and create a token service to generate a token. So let me add the service annotation for this, and at the rate required adds constructor to do the constructor injection for the dependent objects. Final. I'll just take the JWT encoder, which was already created as a bean in the security configuration. And we'll have a simple method to generate a token. So public, I'll generate a string, which is a token itself. So generate token. So I'll simply pass the authentication object to this. And then from the authentication, I'll get the authorities, which is already defined in the user entity itself. Okay. So now I'll just use the stream and then map. And then I will just use the method reference to get the authority. And then dot collect of collectors dot joining. I'll separate the roles if there are multiple roles associated. So just make this as string roles. Okay. The next thing, what we need to do, we need to have the JWT claim set to prepare the JWT token. Who is the issuer? What is the expiry? When it was issued? And what's the subject line, right? All these kind of things. So JWT claim set dot builder dot issuer. So in our case, EPAM systems is going to issue the token. And I'll just define one timestamp. Instant. And here issued at now. And we'll have the subject, which is authentication dot get name, which will have the username itself. And then we have something called claim. And here, this is a reserved role. We need to define it as a scope only. And here we can define the roles. And then expires at, we can use now dot plus, and we can give 5 minutes for the token to expire, and dot build finally. So now I'll just use return this dot JWT encoder dot encode, and we can use the JWT encoder parameters from, just give the claim set to get the token value in the form of string. So this token is completely encrypted, and we have used the encoder over here. So this encoder is having the public key, which is used for encrypting the data, and this private key is used for signing the token, right? So that's the reason I was saying in the diagram, this public key and private key are mathematically linked to each other. The server will be able to decrypt the data or validate the data, whatever it is based upon this private key itself. But in the decoder part, I don't want to decrypt any data. I just wanted to validate the token by using the public key itself. Okay, so that's the total idea. And I will simply go to this user controller and I'll just go to this dot user service dot login. And I will simply pass the user request. Okay. Now what we can simply do, we can just go to this implementation and I will just use the authentication manager bin, which was prepared in the configuration class. So authentication manager, and I'll just go to the this dot authentication manager dot authenticate. So here we need to pass username, password authentication token, and we can get the user request dot get username comma user request dot get password. So now this is enough to get the authentication instance. So once we get the authentication instance, we can simply use the token service. Let me take the token service and let me use the token service here, this dot token service dot generate token, and I just wanted to pass the authentication over here, which will in turn generate a token. So now I'll just change the data type over here and I will just go to the user service and I will also change the return type over here. Now I'll just go to the user controller and here I'll simply return new response entity, and then I'll copy paste this entire line of code because it simply returns a token, right? So I will just use new, there's a token response generic class. I will simply use that one and I'll simply use this, and then http status dot OK. And here in the return type, I'll simply go and change this to response entity of token response string itself. Okay, so this is the total idea. Now, if I just go to this login method again, let me confirm all the steps. Username, password, authentication token. It will generate authentication, and I will just call the generate token, and it is going to generate me the token with encrypted data. Okay, this is all we have done. And now I'll just go to the user controller, and then I'll also go to the configuration to add the login endpoint as a public endpoint. Because if login endpoint is not public endpoint, how the users will log in or register to the platform, right? So v1 /users /login. That's all I need to do. And then I will restart the application. Let's see if there are any errors before testing the application. Good, we don't have any errors. Now let me go to the Postman, and then probably I will use the login, and I'll simply go and send this request. Good, we received the token. That's the first successful step we have made. And now we'll just go to our security configuration, and here I'll just go and simply remove this. Now I'll just restart the application again. If any of the endpoint is not provided here, that endpoint must be hit only with the token. Otherwise, it will never accept that request. Okay, so let's do that test right now. So let me go to the Postman and let me go to this one as well and let me hit the endpoint. It is 403. Good. Now we are going to select the bearer token and then I will just paste the token here and I will just send the request again. Still it's 403. What is the issue? Now whenever we are going to pass the token in the header, the application must decrypt or understand or validate the token in order to hit our endpoint. After successful validation of the token, after successful verification of the token, it has to allow the user to hit the endpoint. So now what we need to do over here, so I'll just introduce one more API, .oauth to resource server, OAuth to .jwt, JWT hyphen, we just have to provide the information to our JWT decoder, because this JWT decoder is going to have the public key, which is used for verifying the token also. See, public key is used for encryption and also public key is used for verifying the token, whether it is valid or not, and whether it has been generated by our application or the platform itself or not. Okay. So now let's start the application again and let's test the endpoint now. Since the token is valid for 5 minutes, I'll simply hit the request again. So I'll just go to the Postman again and then I will hit the endpoint. Now you can see that our endpoint is successfully working fine. Now let's do a role-based authorization to access this endpoint. So let's say role-based authorization is very easy to implement. There is something called @enable. Previously, we were having the global method security, but that is deprecated and they have given this new @enable method security. So once we add this annotation, and if I just go to the user controller and if I just go to this one, there is something called @pre-authorize, and then here we can simply use has authority of, let's say, user. Okay, so now let me go and stop the application and rerun it, because the token is going to contain the user with role as user itself, because we have registered the user with default role as user only. Okay, so now let's go and hit the endpoint again. It's not working. The problem is when we are using the latest Spring security with 6.x version, there are major changes in the security APIs. So here, if I just keep scope underscore user, then if I start and stop the application and start it again, now if I hit the application again, see, it's working, because for all the roles, it will append the scope underscore as a prefix. I have already implemented this in my previous client, but I was wrapping around my head why it is not working, why it is not working. So I have seen that scope underscore is the prefix which is used, and I have enabled the debugging mode where I came to know about this, and I have simply kept the scope underscore. But this is not good, right? So probably if I just wanted to eliminate this scope underscore prefix. For that also we have a solution. So let's go to the user management configuration and let's add one more being public JWT authentication converter and create a being for this. So JWT granted authorities converter and then I need to set the prefix to set authority prefix as empty. Now I'll just create JWT authentication converter and I need to set the granted authorities converter to this. And then finally return JWT authentication converter. This is the only step that we need. Once we do that, we don't need this prefix as well. Now I'll stop the application and I will run this application again. And I'll just go to this and hit this again. So the token is expired. Let me regenerate it. Now this is working. Okay. So that's the total steps that we need to follow to completely implement RSA asymmetric encryption with private and public key approach. Okay. So now this, imagine that this is a server-based application and there can be a number of end users. Like in the flow diagram we have already seen, right? So if you just go over here we do have the buyers, clients, and loyal customers. We will be sharing them only with the public key, and they can encrypt the data, the sensitive information in the form of JWT, and they can pass the request over the API gateway through the server. Now the server will validate the token and respond to the users back with the data, whatever they need. Okay. And even if anonymous attacker gains, in between the request, if he comes and then try to tamper or forge the token, he will never be able to do it, because only with the public key he can do the encryption, but he will not be able to sign the token because it requires a private key. So we are completely handy with our approach to implement high-level security for our application, and we will never give the chance to attacker to tamper the token and send the request to the server and then expect the token from expect the data from the server, something like that. Okay, so this is something called the RSA asymmetric encryption, which completely resolves all these issues: token tampering and re-encryption and token forging, etc. Okay, so that's the total idea of this RSA asymmetric encryption. Now, I just wanted to explain one last point. Let me go to the paypal.com and let me explain you about this. This is a HTTPS website, right? So HTTPS means it's a secured website. Now let's say I just wanted to go to this connection is secure, and then there is something called, let me open that inside my Chrome to make it better. Paypal.com. Here I have connection is secure, and here the certificate is valid. What is this certificate? So this certificate is having the certificate, and then it is associated with the, so we have the public key over here. So whatever, let's say if I just wanted to register with PayPal, so I need to provide my net banking details, or I need to provide my debit card or credit card details, right? So whenever I just wanted to provide all these details, when the PayPal is going to ask our bank with this information, the information which is passed over the network to our bank, respective bank, the data will be encrypted completely with this public key. And only the server which has the private key will be only able to decrypt the data and authorize it and send the back response to the PayPal. So that's how it actually works. So this is something called the HTTPS website, which follows the same pattern, the encryption and decryption kind of techniques. So that's all, and I'll have another session on API gateway with Spring Security implementation with RSA, the same part. Thank you and have a great day.